Hello everyone, welcome back to the course Introduction to Mechatronics. And I'm Dr. Yan Foucault from National Taiwan University. And in this unit, I'm going to teach microcontrollers programming. And we know in our textbook, Chapter 7 is microcontrollers. And in the textbook, actually, it used the PIC microcontroller. That is in this textbook. But actually, I'm sorry. In my lecture, I'm not going to cover the content of the textbook. I'm going to teach some other materials. Basically, I'm going to cover two topics today. The first is the AVR 80 mega 328P microcontroller. So this is different from the PIC microcontroller in the textbook. Okay. And second topic is that I'm going to talk about Arduino, the basic background information of Arduino and how to use Arduino. And I teach this material instead of the material from the textbook because this Arduino microcontroller is easier for you to use. So I hope that this video will help you to get some basic information of Arduino and to help you to start using this microcontroller. So here is the outline of this unit. So first I will talk about what a microcontroller is. Then we are going to look into how the microcontroller works. This is some theory part. Okay, and basically it covers how a computer works. So microcontroller is very similar to a computer. So they are called like modern computing devices. So how do they work? We have to learn this. Then after that, I'm going to talk about one specific microcontroller, 80 mega 328P. And then after this, I'm going to cover how to use Arduino and provide you some hands-on examples. So let's start our first topic. So what is a microcontroller? So microcontroller can also be written as MCU, microcontroller unit. Okay, so we'll see this abbreviation throughout the course notes. So what is a microcontroller? It's basically a computer, very small, teeny tiny computer, and it's in a single integrated circuit. So what is integrated circuit? It is IC. So a computer in a small IC is a microcontroller, and it contains a processor, or you can call it CPU, memory, RAM, and programmable input-output peripherals. Those are the pins here. You see these pins are, we call them input, output, or I/O pins. Okay. And why do we need microcontroller? So the basic idea is that we want something happen. We want to control something. Then we need microcontroller. Because microcontroller has a specific usage that it reads inputs. Say, for example, if you want to control a heater, okay, you want to turn on the heater when the temperature below 0 degrees Celsius, then you need the temperature sensor here to read environmental temperature. And then you can turn on a relay of a heater. So this is output. Okay, it reads inputs and it generates some signal to the outputs. This is how a microcontroller is used for. And so how do we make the microcontroller work? We have to write programs in the microcontroller. And the program is stored in the memory of the microcontroller. And there's some CPU in the microcontroller. So when the microcontroller starts work, it reads the program in its memory and follow the program to work. So for example, if you want to say the temperature, you want to control the heater based on temperature. You control a heater. What do? You will use some structuring programming. Say if temperature is larger or equal to 30 degrees Celsius, heater on, and else heater off. This is some pseudocode. Those are not the actual program, but think about that. You have this example and you want to control heater, and then you write this program into the microcontroller memory, and you plug in the temperature sensor to the microcontroller, and also the heater switch to the microcontroller. Then you can use this microcontroller to turn on or turn off the heater. So why do we want to talk about microcontroller? Basically, they're everywhere. So for example, you can see that in digital camera, you have a microcontroller. When you put a button, you push a button, the camera will shot a photo, will acquire a photo. And in a washing machine, you can program like what clothes you want to wash. Is it wool or if it is cotton? And then it is controlled by microcontroller. And you have a studio system. In a vehicle, there are also microcontrollers and scanner. Like every electronic devices comes with a microcontroller. They are everywhere. Okay, so you can see this as examples. Okay, then that's about microcontroller. Now let's move to internal organization of computers. So I mentioned that microcontrollers are computers. So how does it work? What components does it have? Okay, let's move in. So the basically internal organization of a computer includes a CPU, a central process unit. Okay, and it is used to perform arithmetic operations. And also the microcontroller has or computer has a memory. So memory are used to store data. They can be in any form. Let's say your hard drive, that's a memory. And your RAM, we'll talk about RAM. That is a memory too, okay? And memory is used to record data, to store data. Okay, and a computer also has I/Os, input and output. Okay, so it is used to acquire or to send data from one device to another. So it really depends on what device you want to control or you want to monitor. Okay, so for example, keyboard provides information to the computer. So this is like a I/O device. So does mouse and other sensors. And output has like LCD monitor, printer, or let's say hand of a robot. Okay. Now those three are basic components of a computer. So let's talk about memory first. So the memories are basically the device to store data for a computer. And so like how much information you can store, you need to understand that. And you also have to understand like how the organization of the memory is. Say if you go to a electronic store, you want to buy some memory, and well, the store representatives will ask you like what kind of memory do you want, and the size of the memory do you want. You can say like I want 1 gigabyte memory. Then say that I want the 256 megabyte of memory. So these are the size of the memory. And you also have to know the organization of the memory. So in the modern computers, the organizations are basically 8-bit organization. What does that mean? When you store the information, you want to store 8-bit together. You can store like 1 bit or 2 bits or 3 bits. You want to store 8 bits together. So this is like an 8-bit organization of the memory. Okay. So why is it 8 bits? This really depends. Like we know in the Windows 10, the organization is actually 64 bits. So it varies from one system to another. And when the times move on, these organizations can change. But why do we use 8-bit? Because in traditional microcontrollers, they are 8-bit microcontrollers because it can only deal with information of 8-bit at the same time. So it's like 8-bit microcontrollers. Okay, and that's about memory. So memories are all in different kind of forms. Now we want to talk about semiconductor memories. So there are two kinds of semiconductor memories. One is ROM and the other is RAM. So ROM is read-only memory, and RAM is random access memory. Well, these are the very ancient names, like when the computers are just invented, they give them this name. We call these memories read-only, but actually they're not read-only anymore. We can actually write data in this memory. Okay, so you can see that we have like erasable memory and electronic erasable memory and flash memory. So since you can erase the content of memory, you can write it again. Okay, and this memory ROM is used to store program in microcontroller. Okay, you write program in ROM of a microcontroller. Okay, ROM has a characteristic that you turn off the microcontroller. The information is still in. Okay, for that reason, you want to store your program in the ROM. It's like you store your program in the hard drive of a computer, because when you turn off the hard drive, the information, the data, is still in that hard drive. But for RAM, it's different. When you unplug the RAM, the microcontroller, the data in the RAM will be gone. Okay, so it cannot be used to store the data when the microcontroller is turned off. So basically, you want to store program in the RAM, and this in the ROM, and you want to store temporary information in the RAM. Okay, that's the basic difference between ROM and RAM. So I mentioned that ROM, although it is called read-only memory, it actually can be, the data inside can be removed, and you can program it again. And the latest technology is called flash EPROM. Right? Why does it called flash EPROM? Because the data inside can be erased in a flash instantly. For the old ROM, even though the data can be erased, it takes a long time to be erased. But for the latest technology, we have the flash EPROM. Okay, for the RAM, there are basically two types of RAM. And if you are familiar with computer, you will have some experience with like SRAM and DRAM. Okay, SRAM is called static RAM, and they are made of transistors. Okay, and they are fast but expensive. And for the DRAM, it's dynamic RAM, and they are made of capacitors. Okay, they are cheaper, but they are slower. Okay, and a chip of RAM will look like this. You have some pins; those are the data pins. And you have some pins; those are address pins. Okay. And usually a memory will give you a symbol to simplify the RAM, because when we draw a RAM, we don't want to draw so many pins. Those are very tedious. So what we want to do is we draw like the data pin as this, address pin as this. Okay, that'll be easier. And a memory device must be connected to power and ground to supply the power of the RAM. Okay, so you'll see these two pins. And if you want to access the pin, you have to enable the access. So you need some control pins of them. Now next, we want to talk about the components inside of CPU. So we know CPU is called Central Process Unit, but what do we have inside the CPU? We have first a program counter. The abbreviation is PC. And we have a general purpose registers. Okay, and we also have a arithmetic logic unit. So arithmetic logic unit is used to perform the arithmetic operation. Say we want to add something together. We want to subtract one number from the other. Okay. And or we want to perform multiplication, those are performed by this arithmetic logic unit. And we have instruction decoder, and also we have a status register. Okay, and this is quite complicated, so I don't want to go into the details. I will just make some short examples here. So for example, what is a register? Register is the place you store data inside CPU. So this general purpose register is used to store data inside CPU. Okay? I'm sorry, not CUP, CPU. Okay, and once you store the data inside CPU, then you can use arithmetic logic unit to do some arithmetic operation. Say you want to add the data in R0 to the data in R1 and store the information in R2. Okay, so this is R0, R1, R2. You want to perform this operation. R2 is equal to R0 plus R1. Okay, so this is how the ALU works. Okay, and that's the reason why we need the general purpose register. Okay, and what is a program counter? This is going to count like what line that I am currently now performing in your program. Say if you have a program, if you have the experience of write a program, you know, program have different lines. You have line 1, line 2, line 3, line 4, 5, 6, blah blah blah. And this program counter keep tracks like what line you are right now. If it is in line 2, that program counter will remember now you are in line 2. And if line 2 is performed, the instruction in line 2 is performed, that the program counter will advance, move to line 3. Okay, and what is an instruction decoder? It reads the instruction in a line. Say in line 2 there's an instruction. You read that line inside this instruction register, and then it will decode that line and tells the ALU what operation you want to perform. Okay, so this is how this CPU works. So let's make an example. In the program counter, it counts what line you are currently now performing. Like say in our flash ROM, we have our program. It's over here. Okay, those are assembly programs, so don't worry about them. We are not going to teach about assembly. And each instruction has an address. So address starts from 0, 1, 2, 3, 4. Okay, and so the program counter will keep track the address of each line. So each line there's an instruction. Okay, so what does the PC do is that it retrieves the address number here to the program counter here, and then after you your program counter indicates which line you are, then the instruction decoder will retrieve the program in the flash ROM. So if we move to address 1, okay, then the instruction in the flash ROM will be retrieved to the instruction decoder. To line 2, then that line is retrieved too. to line 3, the line is retrieved to line 4. Again, the program is retrieved to. Okay, so this is how the CPU works, and how does the program counter and instruction decoder are for. Okay, so how does the program work? It basically fetch, means get the machine code or the instruction at the program counter. The program counter is the instruction address. Okay, and the program counter will add 1 automatically. Then the CPU will execute the fetched machine code. Okay, basically it will operate the ALU to do some arithmetic operation. Okay, now let's take a look how computer works. Oh, sorry. How computer works. The first thing we have to make the computer work is to connect all the components together. What components do we have? We have a CPU that we just mentioned, and we have a RAM that we also mentioned in the slide number, let's see, number 9. So this is a memory device. Okay, so remember, for a memory device we have data pins. So we have 8 data pins. You can see these are the 8 data pins. And although we only draw one line, but when we draw the line in this way, that means there are 8 lines. Okay, and we also have several address pins. So for example, in this example we have 8 address pins. Okay, so address pins is if you want to read the content of the RAM at specific address, you need to tell which address you want to read. Okay, so basically this is how why we need the address lines. And we also have some control pins and power and ground too. Okay, so let's go back to slide number 14. So if we want to connect the RAM to CPU, we have to connect what? We have to connect the data bus. That means we want to retrieve the data from the RAM, okay, to the D0 to D7. Now we suppose this is an 8-bit microcontroller. Okay, so your data bus has 8 pins, and also you have to you need address bus. That means you want to tell the RAM which address of the content that I want to retrieve. Okay, so you need several address buses. And remember, like for if we plot a figure using this symbol, that means there are multiple lines. So for the data bus, there are actually 8 lines. Okay, and you also need some control pins. So what are the control pins for? You want to enable the read or enable the write. Then you have to tell the RAM. Okay, the CPU has to tell the RAM if it wants to perform a read or write. So you need this control bus. Okay, and you can connect the RAM, and you also can connect the I/O to the CPU. So this is basically how we connect them together. Now let's take a look how computer works. And this example is based on von Neumann architecture. In a sense, all the CPU, flash ROM, and I/O are connected together. Let's say if we have a flash ROM that contain the program over here. These are binary codes, okay? And we don't understand what the binary codes are, but basically we can convert that to some higher level language that we can understand. So, say for example, if 31H means that you want to move the data from address 17 to a general purpose register A inside the CPU over here. That's 31H. And C4H means you move the data from general purpose register A to general purpose register B. So you move data from A to B. And 26H means you move data from address 6 to general purpose A. So address 6 is over here. You see 5H. That's the address 6. Okay, and then this 81H means you want to move data, not move data, you want to add the data of general purpose register A and the data in the general purpose register B. You want to add the data of these two together. Okay, and then store the results in general purpose register A. And this EAH means you want to move the data in the general purpose register A to address H. So the address H is over here inside the ROM. Now let's see how this program works. So first we have to connect the flash ROM and with the CPU and also with the IOs. And now we can see that they are all connected together. And again, we'll see that they are address bus, data bus, and control bus. Okay, and we know that the CPU has these components. So once we turn on the CPU, we turn on the microcontroller, the program counter will start from 0. And how does the CPU work? The CPU works in this way. The first step, it will fetch the instruction at the program counter. Okay, so these are the program counter number. Okay, this is the first step. Second is that program counter plus 1. And the third is to execute the instruction. Okay, so how does it do that? Okay, so once we turn on the computer, the program counter starts from 0. And the first thing is that it will set address bus 0 because it wants to access the program, the instruction at the location, at the address 0. So the address bus is 0. And it reads the data from outside the CPU to inside the CPU, right? So the control bus is read. So this is read, okay? Then it reads the instruction at address 0 to the instruction decoder. So the instruction at address 0 is 31H, right? So it reads 31 in the instruction decoder. That's the first step, that is the fetch. Then the second step is the program counter plus 1. So the program counter now is 0. Now after it fetches the instruction, it becomes 1. And the next step is to execute the instruction. So what does the 31 mean? The 31 means it reads the data from address 17 to the general purpose register A in the CPU. So address 17 is over here. It reads the data to this general purpose register. Okay, so it's going to read. It's going to read. So the first thing is that it has to set the address bus. The address bus is 17 over here. So it sets the address bus as 17. Then it's going to read. So it sets the control bus to read over here. And suppose that the number, the data in IO 17 is 9. Now it moves this number 9 to the general purpose register A. Now the number in general purpose register A is 9. And it completes the first instruction here. Okay. Now it's going to fetch the second instruction. So the second instruction is what? Your program counter now is 1. It's going to fetch this information C4H at address 1, right? So what does it do is it sets the address bus 1. Okay, and then it sets the control bus read. And then it reads that C4H to the instruction decoder. And then after that, the program counter increase from 1 to 2. Okay? And next step is to execute this instruction, C4. So what does that C4 mean? It means we move the data, we copy the data from general purpose register A to general purpose register B. So because this is inside the CPU, you don't have to control the address bus or control the control bus. You just copy that number 9 from A to B. Okay, so this basically complete the second instruction. Now we are going to do the third instruction. That is the address 2 over here. Okay, so what does it do? The CPU will set the address bus 2, and then it has to read from ROM to CPU. So the control bus is read again. Okay, and it reads from address number 2 over here to CPU. So it reads the content 26H to the instruction decoder. Now it is here again. Okay, then the program counter is going to increase from 2 to 3, and after that, the CPU is going to perform the instruction 26. So what is 26? 26 is read the address of 6, the data at address 6 to general purpose register A. So address 6 is 5H. Now it's going to read that data. So the CPU will set the address bus to 6 because it's going to read 6, the data at address 6. Then it's going to read. So it sets the control bus to read again, and then it fetch the number 5H to general purpose register A. Okay, so we complete another instruction. That's instruction number 2, line 2, address 2 actually. And next it's going to fetch the instruction at program counter address number 3. It's over here, 31H. So it has to set address bus to 3. Then it sets the control bus to read. Okay, then it fetches 81H to the instruction decoder. Then the program counter increases from 3 to 4. Okay, so the next thing is that it's going to perform this 81H. So what is that 81H? It is we add the data at register A and the data at register B, and then store the data in register A. So this happens inside the CPU. So it doesn't have to set the address bus or the control bus, but it actually fetch number 5 and number 9 to the ALU, the arithmetic logic unit, because this is an addition operation. It's arithmetic operation. So we have to fetch 5 to LU and 9 to LU and add them together, and then store the results. That is E, letter E. Letter E means number 14. Okay, so 5 plus 9 is 14. Okay, this E is number 14. Okay, and that is stored in the general purpose register A. Okay, now we are done the instruction at address 3. Now we're going to move the instruction at address 4 over here. So the CPU will set the address bus to 4, and then set the control bus to read. Then fetch that instruction EAH to the instruction decoder over here. Okay, then the program counter will add from 4 to 5. And the next is going to execute the instruction EA. So what does EA mean? EA means you want to copy the data in the general purpose register A to address 7. So A is inside the CPU, it's E here. And 7 is in the flash ROM here. So this is a write operation, in the sense that you want to write, you want to send this E, information E, to the circle here. Okay? So what you have to do is, first you have to CPU have to set the address bus to 7, because you want to write into address 7. Then you have to control the control bus to write. So this is write. And then you send the E to address 7. So this is how the computer works. Now we have learned how computer works. The next is move to one specific microcontroller that I'm going to talk about. That is AVR 80 Mega 328P. Now this AVR is a family name. It is the brand Admiral. Okay, and they have these AVR microcontrollers. And why do we want to talk about AVR microcontrollers? That is because we want to. This is a microcontroller that on Arduino. Okay, let me show you some information here. Let's say, as you can see on the screen here, this is an Arduino board. Okay, and what you can see is that we have a Admiral microcontroller 80 Mega 328P here. Okay, and that's the reason why we want to talk about this microcontroller, because later on we will use it. Okay, let's go back to the slides. So it looks like this. So the schematic microcontroller figure looks like this. This microcontroller has a CPU. It has a program flash ROM. It also has some memory, and of course it has I/O pins. It's just like what we mentioned about a computer. So this microcontroller basically is a computer. Okay, so how it also has some other components. Let's say the timer, other peripherals, interrupt unit, oscillators, but we are not going to talk about them now. And how does this microcontroller look like? This microcontroller has 28 pins, from pin 1 to 28. Now for a microcontroller, you will see this notch over here. Okay, let me show this figure. Here, you see that this microcontroller is the 80 mega 328p, and it's not very clear, but you'll see there's a notch over here. Okay, that notch is the indicator here, tells you which pin it is. Pin 1. Okay, so you see that notch over here, and next to the notch there's a pin 1, and it goes from the counterclockwise direction. Pin 1, 2, 3, 4 till pin 28. Okay, so there are like 28 pins, and these pins, each pin has its name. And for a microcontroller, what you need is you need to supply the power, so you have to connect it to a battery so it can work, right? So you need some at least one VCC pin and one ground pin. And this microcontroller has a AD converter, analog to digital converter. So it needs this pin, and the rest of pins are I/O pins. The rest of pins are I/O pins. They can use for either input or output. Okay, so that's how the functions of the pins are. And now, how many I/O pins do we have on 80 mega 328p? We totally have 28 pins, right? And we minus 5 power pins, and we have like 23 pins that they can work as the I/O pins. Okay, and these I/O pins, each of them has alternative functions. Okay, so what you can see in these parentheses is their alternative functions. They can not only be used as I/O pin, but also as some other function pins. Okay, so it is quite a powerful microcontroller. And so what about this microcontroller? There are some specifications, specs of this microcontroller, and some of them are complicated, so I'm not going to go through all of them. But the basic idea is that it is based on the Harvard architecture, okay? And it uses the RISC instruction. This is by contrast to the CISC. Okay, you may heard RISC before, so this is just for your reference. And these are 8-bit microcontrollers. Okay, so every time you read data, you read 8-bit together. Okay, a complete system on a chip. So it comes with flash ROM, SRAM, EEPROM, and it can interface with USB, SPI, USART, and it operates at this speed, 0 to 20 megahertz, so it's pretty fast. And how much memory do we have on this chip? This is something that we have to care about, because if we want to program a microcontroller, we have to know like how big the program we can write and write into this microcontroller. So here we can see that the flash ROM is what? Your program memory is 32K bytes. Okay, and you have some SRAM, static memory, that is 2K bytes. Okay, and here is the address map of this RAM, these memories. Okay, you can see like this is inside the CPU. The general purpose registers. There are 32 of them. And then we have an internal SRAM and we have external RAM. Okay, these are their address. And also, this microcontroller comes with many functions. Okay, it has 23 I/O pins that we just talked about. It has 6 PWM channels. Okay, and it also has 8 ADC channels. And it has timers. We're not going to use the timers, but those are very powerful peripherals. Okay, and it has a built-in oscillator, so you don't need external oscillator. And it supports the USART, SPI, I2C, those interface. Okay, and that's pretty much about what a ATmega 328P is about. Now we are going to move to something that is more interesting. It's called Arduino. So what is Arduino? Arduino basically is a integrated board of the ATmega 328P. What you can see is that this is a figure of the board. Okay, so we have ATmega 328P here. What you can see about microcontroller that you see there are so many pins. Okay, and how do we use that pins? We usually use those pins on a breadboard. So what is a breadboard? So this is a breadboard. Okay, we can plug in that microcontroller in this breadboard and use it. Okay, it's one way to use the microcontroller, but it is not so convenient. So in Italy, someone just invented this integrated microcontroller. It's called Arduino. It builds in this microcontroller and it connects the pins to some sockets. You can see those sockets. Those sockets are very convenient. Connect those sockets to these pins. So basically using those sockets that you can you don't need to use the breadboard. It's very convenient. Okay, and that's called Arduino. So Arduino is actually a very powerful computer. Not sure if you ever heard about in old computer, Intel 80286, and so the computational power of Arduino is equivalent to this old computer, and this tells us like how powerful this Arduino board is. And why do we choose Arduino to teach? Well, there are many reasons. The first reason is that it's a very common microcontroller integrated board. If you Google Arduino, you'll see like more than 62 million search results. That means there are many resources available in the internet. Okay, and it is open source. So every time you use this microcontroller, there's no charge. The software is free, and you can change the software. You can contribute to this community if you are a good programmer. And it has dominated the market. There are so many people using this microcontroller, and the cost is low. One single Arduino board is less than $30 US, and easy to use. We are going to talk about that very soon here. And it has a very friendly programming environment. Okay, and Arduino is so popular that I'm going to show you some example here. Here you can see that Arduino is a board in this small robot. You can see it's very tiny, smaller than your hand. And Arduino can be installed on clothes like a soft material and used as the direction light. If you turn your head to left, the left direction light is on, and if you turn right, the right direction light is on. It's very interesting, and it's very useful, very handy in education. So in my department, we use Arduino to build robots. Now let me show you one video. You can see here. This robot is going to seek for a red color patch. So it has to pass some blocks, some obstacles. And the main controller is Arduino. You can see that it passed by many blocks and keep moving and keep moving. And keep moving until it reaches the area of color patches. And they are blue, green, and red color patch. But this robot will make circles and seek for the red patch. And then you will go to the red patch and stop before the red patch. And Arduino also can use to build some remote control robots. So this is some one remote control robots that we built by the student in our department, and it's very handy, very useful. And this robot is remote control by Bluetooth. So if you have a cell phone, you can use your cell phone to remote control this robot. Very interesting. And in Taiwan, we have a field robot competition. It's an annual competition that students build robots, and we simulate the tasks we have to do in the field, like watering plants or something like that. And let's take a look how that goes. There's a video over here.
Can you blow my whistle, baby, let me know. Girl, I'm gonna show you how to do it, and we start real slow. You just put your lips together and you come real close. Can you blow my whistle, baby?
There are Arduino boards inside this robot.
You love freak mode, and I'm betting you like girls to give love to girls and stroke your little ego. I bet you I'm guilty, your honor. That's just how we live in my genre. Who in the hell done paved the road wider? There's only one blow and one rider. I'm a damn shame, order more champagne, pull a damn hamstring, tryna put it on ya. Let your lips spin back around, come up. Slow it down, baby, take a look. You blow my whistle, baby, let me know. Girl, I'm gonna show you how to do it, and we start real slow. You just put your lips together and you come real close. Can you blow my whistle, baby? Here we go. Shawty don't even know she can get in it for the low. Told me she not a pro, it's okay, it's under control. Show me soprano, cause girl you can handle. Baby with stars, so then you come up in park clothes. Girl I'm loose, so when my Bugatti the same nose. Show me a perfect pitch, you got it, my banjo. Talented with your lips like you blew out a candle. So I'm using, know you can make it whistle with the music. Hope you ain't got no issues, you can do it. Even if it's no bitch, you never lose it. Can you blow my whistle, baby, let me know. Girl, I'm gonna show you how to do it, and we start real slow. You just put your lips together and you come real close. Can you blow my whistle, baby? Here we go.
And Arduino is very convenient in the sense it also comes with many peripherals, or we call it shells. So what are shells? Say if you want to add a Zigbee to the Arduino, there's a shell you can plug in to the Arduino. If you need GPS, there's another shell. Ethernet to VGA card, motor controller, SD card, joystick, or Wi-Fi, and you can actually stack them on the Arduino board, and Arduino still works. So this is the shells. It makes the Arduino very, very convenient, very useful. And Arduino is not only one single board. There are many Arduino boards. And the most popular one, and the one for the beginner, is called Arduino Uno. Now this Uno in Italy, that means one. Okay, and there are many other Arduino boards. If you want to a tiny one, you can use this Arduino Nano or this Arduino Micro. They are tiny boards. Okay, if you need Arduino that is more powerful, you can use this Arduino Mega. It has many pin outs. So every Arduino is for different purposes. And here we can see that Arduino basically was developed back to 2005, and so after many years, and Arduino changed from one board to another. And this is a magazine that talk about like the family trees of Arduino. It's pretty crazy, but you can see that all Arduino has different develop time, and they have different develop purposes. And so for example, if we want to look into the 8-bit microcontroller, that is 80 Mega 8 series, and if we want to look into the 32-bit Arduino board, that is 80 Mega 32 8 series. So they are all for different purposes. And now we look into this one Arduino. We want to know, we want to understand what we have on this single board. Okay. Now this Arduino board has 180 Mega 328P microcontroller that is over here. Our MCU is over here. Okay, and it has a USB to serial converter, that is this chip here. So here we have USB that can be connected to the computer. And also, like how does the computer talk to this MCU? We need a converter. So this converter will convert the USB signal to a serial signal. And this serial signal can be used to program this microcontroller. And it also has built-on LEDs. So you can see this LO here. That's a built-in LED. And TSRX are built-in LEDs. And there are so many resistors on this board. And there is also a 16 megahertz crystal and oscillator. You can see this one is an oscillator. And we have pin out sockets. Those are the pin out sockets. And we also have power regulator. You can see this power regulator, and it works with the capacitors. These two are capacitors together as the power regulator. So if you don't plug in the USB of the Arduino to a computer, you can actually plug in this Arduino to batteries. and it can still work. Okay, so if you decompose the Arduino, the components will basically look like this. It's like you put so many different components together and it becomes the Arduino board. And as I said, the major components are Arduino itself. That's the brand of the microcontroller. And we have a crystal oscillator. And we have a power regulator. And a USB to serial chip. That's a square chip over here. And this is a schematic diagram of the Arduino. And I'm not going to talk about the details. This is just for your reference. So let's look into the Arduino itself. Now we talk about that Arduino has an USB socket that we can use it to connect to the computer. And we also have power input. Okay, and there's a reset button. If the microcontroller doesn't work, you can press this reset button and it will power off, then power on the microcontroller over here to make it work again. And in Arduino we have many pins. We have digital pins, okay, and we have analog pins, but the analog pins can work as digital pins. Okay, we have some power pins. So the Arduino itself can supply power to some simple electronic components like an LED or things like that. Okay, so it's very useful. So you can see 5 volts and ground, okay, over here. And so let me ask you a question. How many pins are I/O pins? How many I/O pins? Does an Arduino Uno have? Okay, we can see that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Totally, what? 40 pins of digital I/O pins here. And we have 6 analog inputs, A0, 1, 2, 3, 4, 5. 6 pins here. So totally we have 14 plus 6, that's 20 pins. We have like 20 I/O pins on Arduino. And this is important because this tells you that at most you can control 20 devices, or you can read data from 20 devices. You can connect to 20 devices. This is the I/O capability of Arduino. Okay, and I have to point out there are some special digital I/O pins in Arduino. You see those delta symbol before numbers 3, 5, 6, 9, 10, 11. Those are called PWM pins. Pulse, width, modulation pins of Arduino. Okay, they can use to control DC motors using PWM. Okay, hopefully we'll have a chance to cover that later, but not today. Okay, and that's pretty much it. And here we have some key spec of Arduino, and the very important thing here is that for the input voltage that we use to plug in this power, so we have to connect this to battery. if Arduino is not connected to computer. In order to make it work, you have to connect it Arduino to battery. And the battery has to be between 7 to 12 volts. 7 to 12 volts. And totally you have 20 I/O pins. Okay, and each pin can supply a power up to 40 million amps. Okay, so this power is not so strong. Basically, you cannot drive a motor using Arduino directly. Like driving an LED is okay, but not motors. Okay, now let's back to the I/O pins. Now I talked about that we have 80 mega 328P on Arduino, and this 80 mega 328P has 23 I/O pins. But Arduino only has 20 I/O pins. Why is that? There are 3 pins missing. Okay, that is because in the 80 mega 328P, where is it? Sorry, overshoot. Almost here. Okay. We have 1 pin that is used for reset. So this is connected to the reset button. So it occupies 1 pin. And it also uses 2 pins as the oscillator, like these 2 pins, the external oscillator. So out of 23 pins there are 3 pins used by other purposes to reset or to connect it to the oscillator. So there are only like 20 pins available. Okay, just some take-home message why the numbers mismatch. Okay, now we are going to explore how the Arduino works. So first thing we have to do is to go to the Arduino website. Okay, and here I provide website address. It's http://arduino.cc. So you click this arduino.cc, and suppose your browser will open and go to this web page, arduino.cc, and this is the official website of Arduino. Okay, and it has many different resources on this website. So please take a look if you have a chance. And what I want to talk about is that if you want to buy some Arduino, the official one, you can buy it from here. Okay, but these are in sold in Europe. Okay, and if you want to download software that we can use it to program Arduino, you have to click this software button, and then you scroll it down. You can see if you run Windows, you can download the Windows installer. Okay, or if you use a Mac, you can download this Mac version, and if you use Linux, you can use this Linux version. Okay, just by clicking one button, then you will download the program automatically. And if you want to understand what Arduino products are available, you click this Arduino products Arduino, and you can see that there is a map like for entry level. Okay, you can use Uno, and you can click Uno, and those are the Uno boards, and it has some description talking about like how the Uno can be used for. And if you need some board that has enhanced features, let's say the dual board. The dual board is very powerful, ARM CPU, okay, and many pin outs, then you can use this dual board. And there's some description here too, okay. So this is about the products. And if you want to learn Arduino, you can come to this learning tab, then click getting started. And there are many topics. You just follow the topics and the examples one by one, and then you can learn Arduino. And the most useful thing is here. There's a forum. So forum is a discussion board that people can come here and post their problems. If you encounter a problem, you post it here, and then somebody will try to answer your question. So this is very useful. Now, this is the Arduino web page. Let me go back to here. Now please go download the Arduino program to your computer, and we will start programming the Arduino shortly. And before we try to use Arduino, you have to remember one thing, that this device is a very fragile IC device. So please do not handle the Arduino in this way. So how do we have to handle Arduino? So basically, if we want to pick up one Arduino, you have to hold their pin sockets from the side way like this. Don't touch the bottom pins or those metal parts. They will make the Arduino suffer static electricity, and you can potentially damage those boards. Okay, and now the first program that we are going to try on an Arduino is Blink. So this is the very first program on Arduino. So what is Blink? Blink is to blink the flash, the LED. The basic idea is that you connect an LED to the Arduino, and you want to make the Arduino flash, okay? But fortunately, we don't need an LED. Arduino has a built-in LED. It is here, and it is connected to pin 13. Okay, so this is what you have to remember. Okay, and how do we program Arduino? So basic idea is that we start a program using the Arduino environment. Then we compile the program, then upload, or say download the program to the Arduino. And when you do the uploading, you'll see that TX, RX, LED over here are flashing. And then your program will start to run. Okay? So basically, the idea is that you write the program. And second is you compile the program. And third is you upload the program to Arduino. Okay, so basically these are the 3 steps that we want to do. And the very first program is here, the Blink program. And if you don't know where to find program, you see there's a link here. You just click the link, and it will bring you to the Arduino web page and show you where the program is. So the program is over here in the very bottom of this page. You see this is the Blink program. Okay. So what does that this Blink program do? It turn on the LED on Arduino for 1 second, then turn it off for 1 second, then turn it on for 1 second, then turn it off for 1 second, and it do this forever. Okay, so let's practice how to do this. So first thing is that we have to open the Arduino program. That is for me over here. Okay, so this is the Arduino program that we have. This is the Arduino environment, software environment. Now, what you have to do is to connect your Arduino to the USB over here to the computer. And once you connected your Arduino to the USB, you'll see that this LED on is on. Okay, if you turn it off, you'll see that LED is off now, and you connect it, it is on. Okay, and this is the reset button. When you press the reset button, that LED will turn off and on. Okay, now once you connected Arduino to the computer, what you will see is that you go to the tools, and then you choose your port. Okay, and here your serial port COM3 is a Arduino board that your computer will detect this Arduino board. You choose this COM3. Okay, now so the computer knows which board, which COM port it has to download the program to. Okay, and after that we have to open the Blink example program. It is actually a built-in example. So you go to the file, and then you go to the examples, go to the basic, and there's a Blink. Again, go to the file, examples, basic, and Blink, and you click this Blink. It will turn on another window, and we don't need the original window, so we just need this window. Okay, and in the bottom of the window you'll see this is the program that we have. Now if we want to check if this program is works okay, then we can press this button, verify. Press this button, the program will start to compile, and it says compiling sketch. Okay, then compiling down. That means this program is working okay. Now, if we want to download the program, okay, or upload the program, there's a button, upload here. So what we want to do is to upload this program. When we hit this button, and when it's uploaded, this LED L over here, LED L over there will start to blink. Okay, let me hit this upload program, and you see that LED. Okay, it start to flash. Off, on, off, on, off, on. Okay, that's how this program works. And when we hit this upload program, you'll see these two LEDs, TX and RX. They are flashing too, because these TX RX communicate with this 80 mega 328p microcontroller. It writes down the program from USB to this program. Okay, let's see it again. Let me hit upload. When I hit upload, you'll see these TX RX are flashing. Okay, although it's very fast, they are flashing. Okay, this is how we actually upload a program to an Arduino. And I pretty much explained the 3 steps here. One is write a program. Two is second is a compile program. Third is to upload the program. And this is a 3 step to program this Arduino. It's very easy and very straightforward. So the explanation of these two buttons are the compile check and the compile and upload buttons are here on this page. Okay, and now we have to introduce some terminology of Arduino. And to know this terminology, you can see the posts or the articles on Arduino official website, and you can learn by yourself. So these are very important ideas. So what is a sketch? It's basically a program of Arduino. Okay, so usually people call it a sketch, not a program. Okay, what is a pin? An input or output pin connected to something. Okay, and what is the digital? Digital are values that is either high or low. Okay, as a digital output or input can be either high or low. Okay, things like that. Then this is high and this is low. Okay, so if it is digital, that means if it is a digital output, that means the output can only be either high or low. And sometimes those high signal is equivalent to 5 volt, and those signal are equivalent to 0 volt. Okay, that is the digital signal. And what is an analog? Analogs are value that ranges between some certain numbers. Say, if you have a small number that output is 0 and a large number that output is 225, okay, and your analog output can vary from 0 to 25 continuously. It doesn't have to be like the digital output that has only the option of either 5 volt or 0 volt. Okay, so this is analog. And then we have to further explain the Arduino sketch and how it works. So a Arduino sketch or a Arduino program, and it's pretty much a C or C double plus program, very similar to that. Okay, and how does it work? Okay, an Arduino program has 3 blocks. The first block is the global variable, that is in blue, and second block is the setup, and the third block is the loop. Okay, so what's the difference? So if you are familiar with the C program, you know that for a global variables, it is used to declare what variable it is. So you have to declare, say, it's an integer, so it's in int. If it is a character, it's char. If it is a double floating variable, you say you declare is a variable as a double. Okay, so those are variables. And the second block is setup. So what is setup? The program you write is in setup. It only runs once. It only runs once. Okay, so what program we need to do in the setup? That means if you need to perform this program only once, you write the program in the setup. And by contrast, if you want the program to be run again and again and again automatically, then you write it in the loop section. So the program in the loop section will be performed automatically again and again and again. Can you write this kind of program in a loop? So for example, the blink program that we just wrote, you have to turn on the LED for 1 second, then turn it off for 1 second. Then you have to do this automatically again and again. Then that program has to be written in this loop section. Okay. So let's take a look of the blink program that we just write. So the first section is the first block is the global variables over here, and second is the setup over here, and third is the loop over here. Okay, so blue, green, yellow, 3 different colors. Okay, so what do we do in the global variables? We have to declare that pin 13 is the pin that we want to generate the on-off signal. Okay, why is it pin 13? Because pin 13 is connected to an LED. Okay, so this LED pin is 13, and 13 is an integer, so we declare that is an integer. Okay, so this is global variable. And next is the setup block. Setup block. In the setup block, what do? We have to declare if one pin is used for input or it is used for output, and we have to make it clear. Now this pin 13, the LED pin, is used for output purposes. So we have to declare that this pin is output. So we use one command that is called pin mode. Pin mode parentheses 13 is the pin you want to set the pin mode, and then it has to be set as output in this example. So we put output here. If it is used for input, we can write input here. Okay, and now this has to be done only once. The next is the loop block. In the loop block, it is a program that the microcontroller will run it again and again. So what do we do here? We want to turn on the LED for 1 second, and this takes 2 instructions. First is you want to make the LED pin remain high. Remember that high is 5 volts. So you supply some voltage to the LED, and LED will be turned on. Okay, so the command you want to write high voltage into it is called digital write. Digital write, in the parentheses, the first parameter is the pin number, and second parenthesis is high or low. Okay, you can write it high or low. Okay, there are 2 choices, or you can write 1 or 0. 1 means high, 0 means low. Okay, then after you write appropriate voltage to the LED, you need a delay, because microcontroller works very fast. If you don't write a delay, you won't see what is happening there. Okay, so you need a delay for 1 second, and now the unit in this parenthesis is millisecond. So that's the reason why we need 1,000 here. Okay, after you turn on the LED and make a delay for 1 second, you have to turn it off and then delay for another 1 second. And now the program is in this loop block, right? So the program will be performed and comes back to the very beginning, and be performed and comes back to the very beginning, and be performed, comes back to the very beginning. And this is done automatically. So this is how the program works. Now we have to talk about more about the programming in the Arduino environment. First thing is to talk about variables. Okay, so as I said previously that programming in Arduino is very similar as programming in C. Okay, very similar to C language, although there are still differences. So for the variable types that we have in Arduino, we have Boolean, that is true false problem, true false variable. or character. So character are in ASCII codes, okay? And we have integer, okay? And integer, we also have unsigned integer option, okay? And integer is 2 bytes, a 2 bytes variable. So you can see like the range of variable is here. And also we have a long variable. Okay, it is a 4 bytes variable. Okay, the range is larger, but it also needs more memories. And we also have float. Okay, those are the variable types we have in Arduino. And for the operators, there are 2 types of operators. One is the arithmetic operator. That means we have addition, subtraction, multiplication, division, and remainder. Okay, and for the arithmetic operation, you need assignment. Okay, and the other is rational operation operators, or say logical operators, and those are equal to, not equal to, less or equal to, larger or equal to. Okay, and if you want to see the complete list of the operators, you can click the link here in the very bottom of this slide, and it will provide you more information. And so for the programming commands, like what function do we have in Arduino? These are for the digital IOs. So what do we have in Arduino? We have pin mode. Pin mode is to declare if this pin is used for input or output. Okay, so you have to assign like what pin you are going to declare and what mode you are going to declare here. So pin is a number. Okay, mode is input or output, or 1 or low, or 1 or 0, high or low. Okay, I'm sorry, input. This mode is input or output. Okay, and for the digital write, this function, you can use this function to manipulate the output of a pin to make it high or make it low, make it 1 or 0. Okay, so you have to choose what pin you are going to manipulate and what value you are going to manipulate, make it high or make it low. And there's another function called digital read. So write is to make a pin high or low, and digital read means you read if this pin is high or this pin is low. Okay, then you can do some judgment to change to make the Arduino perform different tasks. Okay, so this is called digital read. So digital read a pin, it only reads the pin, and pin can only have 2 conditions. One is high, that means the pin is connected to a 5 volt power resource, or the pin is low, that means the pin is connected to ground. So this is the 3 functions that we will use. Okay, so as in the Arduino programming, it's very similar to the C programming. So we also have control structure. Okay, so what control structure we have? We have if, else. Okay, and there's a, in the parentheses after if, that is the condition. And in the condition, we have to put in the rational operators over here. Okay, very similar to C programming. And we also have for loops and while loops and switch. Okay, and for others, like if you want to write commands in Arduino. It's very similar to C programming. Okay, those are for commands. Okay, and in the end of line, you need a semicolon to declare that this is the end of the line. Now we are going to move to our next example. And before we do that, we have to introduce one more thing. That's called solderless breadboard. So basically a breadboard. So what is a breadboard? It is used to connect electronic components. Okay, and the ideas of breadboard is that some pins on this breadboard are connected together. Let's see. Now you can see that this red line connects all the pins here. So that means all the pins here are connected together, and the blue line here means all the pins are connected together. It's inside that breadboard that we cannot see. And also for this pin A, B, C, D, E, you can see these 5 pins are connected together, connected together, connected together, connected together. And so how do we use a breadboard? Let's say if we want to say drive an LED, so we have a battery here, and we have to drive this LED. Let's draw a symbol of LED. So LED, sorry, I have to redraw this. So this is an LED. Okay, and if we want to drive an LED, we need a resistor here. So if you make a circuit like this, the LED will be turned on. And if we want to connect the battery to LED and to the resistor, it's very cumbersome. You have to solder them together. By using this breadboard, you don't have to solder them together. What you can do is, let's say if you have an LED, one pin is over here. Now the LED is here. Okay, you make another pin over here. Okay, now remember, these 5 pins are connected together, right? So you can connect a pin of a resistor over here to a pin over here. Okay, and these 5 pins are connected together, right? So you can connect the pin of this to a battery. So let's say the battery is over here, and you connect the pin of the battery to a pin over here, because these 5 pins are connected together. Okay, so you don't need solder, you just put them together, and this is why, and this is how the breadboard works. And let's see a actual breadboard. Okay, so this is a breadboard, and as I said that on this breadboard, you can see that all the pins on this blue line are connected together. All these pins, and all these pins on the red lines are connected together, and the 5 pins A, B, C, D, E, these 5 pins are connected together. It's inside the breadboard. You can open it up, but that will probably damage your breadboard. So these 5 pins are connected together. Okay, that's a breadboard. And our next example, we will use the breadboard. Okay, our next example is to use a button to control LED on Arduino. That means if we have a button, we press the button, okay, the LED is on. And if we don't press the button, the LED is off. Now suppose you have a button here, okay, you press the button, this button is connected to 5 volts, right? And now at this pin that is 5 volt here, okay, and if you connect this pin to a voltage meter, it will turns to a 5. You have a reading of 5, okay, and so now we have a battery here. That's the reason why it works. But if you don't press the pin, you make it as an open circuit. Okay, what's the reading here? The reading here is actually unknown. When it is an open circuit, the pin reading here is unknown for open circuit. Okay, so this is open. This is open. So that is not what we want. We want, when we want to use a button, we want the reading of the button is high, is 5 volts when the button is pressed. And we want the reading of button, not button, the reading of the pin is 0 volt, it is low. Okay, when it is open. Okay, so in order to make it happen, we have to add a resistor here, resistor here. So what happens if we add a resistor here? When this button is open, now this pin is connected to what? To the ground of the battery. So now the reading is 0 volt. The reading is 0 volt. That's the reason why we need a resistor there. Now we replace this voltage meter using an Arduino, and we connect this pin to pin 2, pin number 2 over here. Okay, and this is the circuit that we can use to build this bottom example. But there's another thing that we have to consider, that in Arduino it comes with some power source, right? There's a 5 volt, there's a ground, okay? So do we need another battery over here? No, actually we don't. We can use the 5 volt from Arduino. Now the 5 volt is this blue line over there, okay? This is 5 volt, okay? And the ground is over here. And we can see that ground is connected to a resistor, okay, and connected to this pin 2 over here, and switch is over here. So these circuits are identical circuits. It is just that we use the 5 volt from the Arduino rather than use a battery. Okay, so this is a schematic diagram. So how do we actually build the circuit? And here's the actual circuit over here in the bottom. And in this circuit, we can see that we connected the output from the switch to pin 2. Okay, we have a button over here. The output from switch is pin 2. Okay, and there is a resistor. After the resistor, we connect it to ground. This black line is ground. This blue line is 5 volt. So after the resistor, we connect it to ground. You see that black line that is connected to the ground pin of Arduino. Okay, and on the other side of the switch, it is connected to 5 volt. So on the other side of switch, you see over here, this is connected to the 5 volt of Arduino. Okay. Now, you may ask me a question like, so here is a switch. Now here's a button. That button has 4 pins. So we enlarge that button. That button has 4 pins, but this button has only 2 pins, right? So, how this button works? Now, in this button, originally these 2 pins are connected inside the button. These 2 pins are connected inside the button. Okay, so when the button is not pressed, these 2 pins are connected together. These 2 pins are connected together. And when it is pressed, those 4 pins are connected together. Those 4 pins are connected together. Okay, so once you press the button over here, all the 4 pins are connected together. Okay, what does that mean? That means you have this 5 volt that is connected to this resistor. This 5 volt connected to this resistor, and it connects it to this ground signal. And your 5 volt is here. Okay, so your button is the 5 volt is here across that resistor, and this pin, because this is ground over here, 5 volt over here, this pin will read 5 volt when the button is pressed. But when the button is not pressed, okay, this 5 volt doesn't go across this resistor. Okay, the resistor is connected to this ground, and this ground is connected to this pin 2 over here. Okay, so the reading when the button is not pressed is ground, or say 0 volt. Okay, so when the button is pressed, your pin 2 is 5 volt. And when the button is not pressed, your pin 2 is ground. Okay, now that's how we actually make this circuit works. So let's connect this circuit now. Now let's see, we have a circuit over here that's pretty much connected with a button over here, a resistor over here, and one end of resistor is connected to ground. That is in black, the line in black. And the other side of the button is connected to red line over here. Now we want to connect this to Arduino. Now remember, the red line is 5 volts, and the black line is ground. So we connected them together to the Arduino, to the appropriate pins. Okay, it looks like this. Now we have to connect. We need one more wire to connect this button to the pin 2 over here in the Arduino. So this pretty much complete the circuit that we have. Now after you complete the circuit, next thing you have to do is over here, the next slide, to run the sketch code bottom. Okay, so let's run it first to see if it works. Okay, let's go to the Arduino program, and then we open another example, that is digital bottom. Again, we go to Files, Examples, then Digital, then Bottom. Okay, and this is the example I have on my slides. Okay, the example is in the very bottom over here. Okay, now after we download this program, is supposed to work. Let me download this program to my Arduino, and we can see on the screen that so this is the Arduino and my breadboard. Okay, and now when I press the button, the LED is on. When I release the button, LED is off. So LED is over here. It's very small, so maybe it is not that clear. Let me see. Let's try this. When I press the button, it is on. When I release the button, it is off. On and off. On and off. And that is how it works. And now let's take a look of the sketch that in this example, the bottom example. Now in this sketch, how many pins do we use? Actually, we use 2 pins. One is the bottom pin. That is pin 2 over here. And the other is the LED pin. That is pin 13. Okay. And we also need one variable that is used to record the bottom status. That's called bottom state. Okay, when the bottom state is 1, that it means that bottom is pressed. When the bottom state is 0, that means the bottom is not pressed. So this is the global variable. So what do we do in the setup? In the setup, we have to declare that pin 2 is used as input and pin 13 is used as output. So here we declare that LED pin is the output and bottom pin is the input. Okay? And what do we do in a loop? In a loop, we keep checks if this pin is this pin 2, the reading of this pin 2 is high or the reading of pin 2 is low. Okay, and if it is pin high, we turn the LED on. If the pin is low, we turn off the LED. So we need basically the digital read function to keep checking the bottom pin. So this bottom pin can be either high or low. Okay, and it restores the result in its variable bottom state. Okay, if the bottom state is high, now we use if structure. If the bottom state is high, now remember, if you want to judge, use rational operators, judge a variable that you need double equal sign, right? Okay, if the bottom state is high, okay, then you digital write LED pin high. Else means if the bottom state is low, then you write the digital write the LED pin low. So this is basically this function. It's pretty straightforward. Now let's move to our last example, tone. So in this tone example, we want to use a buzzer, over here to make sound, and we connect the buzzer to the Arduino pin over here. Okay, and for the buzzer that connect to pin 8 and pin ground of the Arduino. So how do we make a buzzer make sounds? We generate waves from Arduino to the buzzer. Okay, so what waves can make a buzzer? What kind of waves can a Arduino generate? Like waves can be sine wave, square wave, triangle wave, seesaw wave. So what kind of wave do you think that Arduino can generate? So basically, Arduino has digital outputs. In a sense, your output always looks like this. It's either high or low, either high or low. So basically, Arduino can only generate these kind of waves. Okay, so the sound that you will hear is not so perfect that we will hear the sound later. Now what we want to do is to wire the Arduino to the buzzer. So let's take a look of what that we have here. Let's see. Let me turn on the screen. And now we have our Arduino in a breadboard. Now, and this is our buzzer. And you can see on the buzzer there's a plus signal. That means that pin is the positive pin. Now we put this buzzer in the breadboard, and we connect the negative pin to the ground of Arduino, and then we connect the pin, the positive pin, to the pin 8 of Arduino. So we pretty much finish this wiring. And now we want to download the program. So the program is here in File Example, Digit Tone Melody. Again, it's File Examples, Digital and Tone Melody. Then you can look at the program in the very bottom here. Okay, now we want to download this program to the Arduino, and we hit this button, download, and it starts to compile the scratch and download the program. And when the program is downloaded, you can hear that the buzzer making the sound, and the sound may be very small, so I'm going to use my microphone to make you hear the sound. Give me a second. And we will download the program again, and the screen will hit upload. Okay, now I believe you hear that the sound already. So that's basically this example. So how does this program work? Let's take a look here. This sketch code called Tone Melody. Okay, and it has a header function pitches.h. So what is in the header function? Let's take a look over here. You can see when we open this example, it's not only one sketch file. There is a pitches.h file, okay? And you can see this pitches.h file define the notes. Say, for example, you have a C4 notes and the frequency is 262. So what is a C4 notes and what is the frequency? This frequency is the frequency of these notes. We know that for our music, there are notes C, D, D, E, F, G, H, G, A, B. Those stays for Do, Re, Mi, Fa, Sol, La, Si. Okay, C, D, E, F, G, A, B. So in pitches.h, it defines the frequency of each notes. And C4 is the middle C that we commonly use. Okay, so in this melody, variable melody, it defines what notes we are going to play. So this is Do, Sol, Sol, La, Sol, Si, Do. Okay, those 4 notes. Again, those are Do, Sol, Sol, La, Sol, Si, Do. Those notes. Okay. Then for each note, it has a different duration. And the duration can be either a quarter note or eighth note. So this number, when the number is larger, the duration is shorter. If it is a quarter note, that means it plays for a quarter of a note. Okay. If it is eighth note, it means it plays for a quarter at the eighth of the note. So for example, this variable note duration, it records like how long each note is going to be played. We have Do, Sol, Sol, La, Sol, a break, Si, Do. Okay, so when it is fourth note, that duration is longer, and when it is eighth note, the duration is shorter. Okay, and this is the global variables. Okay, now because we want to play the music for only once, we put the program here in the setup. Okay, so for the setup, we play the note one by one. There are totally 8 notes we want to play. Okay, including one break. Okay, so we have 8 notes to play. We use 1-4 structure, and we play the notes from note 0 to note 7. Okay, and the note duration is actually 1000 milliseconds divided by the note duration over here. So that, for example, the first note, the duration is 1000 divided by 4, that is 250. The duration of second note is 1000 divided by 8, that is 125. So the duration of the second note is shorter. Okay. Then after that, we call a function tone. That is a built-in function. Tone to play the tone at assigned duration. Okay, assigned frequency and duration. So this 8 means the pin 8. So remember, our pin is connected to pin 8, right? Our buzzer is connected to pin 8. This is the pin. Okay, and this is the frequency. And this is the duration. So it's pretty straightforward. You play the tone at a pin using some certain frequency and some certain duration. Okay, and you also put pause between notes. It's over here. and there's a delay pause between notes. So after the play, you use no tone to turn off the buzzer. So this is basically how this example works. And on slide number 53, you can see the further readings, like how the Arduino work. And if you are interested in ATmega 328P, you can check its website. And for more information, you can check some other website. Those are for your reference. So also, if you are interested in the AVR or ATmega 328P microcontroller or Arduino, either check their website or their reference sheets. And so this is what we have for today, and thank you very much for listening. Goodbye.